I'm here in the office of Professor Klaus Thurau in the Department of Physiology of the University of the Bavarian capital of Munich. The occasion is to interview Professor Thurau in connection with the legacy project of the International Society of Nephrology. As someone who has trained and worked with Professor Thurau, it is a great pleasure to be able to do this. Let's begin by exploring your educational background. Klaus, why did you study medicine among all the other possibilities?
As often in life, it was a happy coincidence. When I was at a very young age, about 16, 17 years old, I met in a small place in North Germany where the family lived after the war, a highly intelligent and educated medical doctor. And often at this age, it's a personality which impresses you and gives you some direction also for your future life. And I think that was really the starting point of getting interested in medicine. And so it was a logical consequence. And then after I finished high school, that I went to the medical school in Erlangen first and then continued in Kiel.
So I assume that when you first went to medical school that you planned to become a doctor. So why did you then switch over to look for a career in physiology?
Well, as a medical student, you never plan to become a physiologist. I certainly was more interested to become a surgeon at that time. And before going to a surgical department, I decided to go first to a department of physiology or biochemistry, and in any case, to get some scientific background on which you then can develop an academic career planned in surgery. So it happened that I decided after the medical school to join the Department of Physiology in Göttingen. The director of that department was Professor Kramer, and it was the exposure to that unique man and the joy I had in doing research that I finally decided not to go back to a medical department, Department of Surgery, but to continue in physiology. The original plan was for 2 years, and it became a lifelong entertainment.
So you never ever practiced medicine. There must have been something very convincing about Kramer. What was it really that was so extraordinary about this man?
Well, it was his enormous potentiality as a scientist. He had a broad interest in many areas of physiology, not only restricted solely to the kidney, but also circulation and blood analysis and other areas. But I think what fascinated not only me, but many of my colleagues working with him at that time was his stimulating and intellectual approach to science. He was so proud of everyone who came up with new ideas. He never was jealous about great ideas others have developed. And besides that, his enormous function as a scientist, he was an educated man and was an expert in literature and music, two aspects which also fascinated a young man working with an older colleague. And I think it was this atmosphere which Kramer created, which made it so fascinating and so attractive to work with him. And I should say, over the years, we became very close personal friends. And I think it was one of the greatest things in my life to have such a friend.
Well, Kramer also apparently was extremely willing to share anything he experienced with people around him. Can you recall special events or things that he initiated and that were totally specifically Kramer?
I think one should know that Kramer, after the war, was for 3 years in the United States, working in physiology, and returned first to the chair of physiology to Marburg, and then took over the Department of Physiology in Göttingen. And he brought a very international flair to Göttingen. And one occasion I remember very well, when he was organizing, and I think that was one of the very first symposia after the war in physiology in Germany, that he arranged a symposium which brought together scientists like Heinrich Wurz, like Karl Gottschalk, like John Pappenheimer. And it was one of these great events specifically for young people and young fellows in the department to be exposed to these giants in the science. And I think that was one of the greatest things. Kramer always tried to expose the younger scientists to the experts and really great scientists internationally wise.
And John Boylan, right?
And John Boylan is a very special case. I mean, John Boylan came to Kramer on a sabbatical into Göttingen, and became a very, very close friend of Kurt Kramer, and also to me, which lasted for whole his life. And John Boylan was the ideal counterpart to Kurt Kramer, because he was so much interested in literature and music too, so that Kramer could really enjoy talks and discussion and evenings with John Boylan, and it was for us one of the greatest things to be among these two people and learn and experience their competence.
It is often said that the part of the attraction of the Göttingen Institute was its social life, and that the soul of it was Kurt Kramer. Were there special events that where Kramer pulled the institute together in non-scientific context?
Oh, definitely. I mean, one of the greatest things which he was so proud of was at the Carnival, Faschingstime, to have all members of the department, the students, and the students from outside of the department to join for one of the greatest festival and feasts. We changed the department into a club, and it was absolutely fascinating to see Kramer among this group of youngsters and enjoying social interaction with everybody. He also was extremely effective in helping people in the department, so he really looked after the individuals very carefully and gave his help whenever it was needed.
So let's turn to your career as a physiologist. I had the impression that career progressed extremely rapidly. You started in about 59, 58, 59. When I came to your lab in 63, you were already a made man, as some would say. So why do you think you were so successful so fast?
Well, I think one attractive aspect was that we had been working on a forefront topic in physiology in general, and that was the analysis of renal hemodynamics and the intrarenal distribution of renal circulation. Not much was known at that time about these different areas in the kidney, how they are perfused with blood, and what the function of the blood flow in these different areas is. And second, I think in '59 I went to the United States, to Washington, and worked at Walter Reed Army Institute of Research for 2 years. And at that time I was exposed to many colleagues in the United States with whom I established friendship and scientific interaction. And I think these two things, working in an attractive field of physiology and having international experience, helped very much in my own career in Germany, and was no question that at that time also there was an enormous need in Germany for scientists, so the positions became available and helped very much to develop own research and own research groups. I think these are the major factors in promoting my own career.
You obviously were interested in maintaining and seeking international connections. Why was that so important to you?
I think science in general is an international affair, and regional science as it was experienced in former times in countries which were not open to the world were a very bad example for science, how to develop science and how to promote science. So the international aspect in science was from the beginning on one of I was extremely interested in, and specifically to be exposed and also to become friends with very important scientists. At that time, I just should mention a few names with whom I became very close. It was Don Selding, Gerhard Giebisch, Floyd Rector, Selkort, Karl Gottschalk, Würz, De Wardener. I mean, and that exposure to these excellent scientists immediately helped your own science very much, because you measured your own science on science of those very successful and productive scientists. So internationality of science was for my whole life one of major driving force in my own career and my own activities.
It's my impression that the knowledge about the kidney function, both basic science as well as clinically, developed extremely rapidly in the 50s and early 60s. Why do you think that happened at that time? Was it a coincidence between method availability and the right people, or why do you think so much was done in that time period?
Well, I think you're right. I mean, the availability of new techniques beyond clearance techniques that's in the time of Homer Smith pushed enormously the analysis of intrarenal functional details, not to speak of the micropuncture technique, which was the most used technique in those days to analyze intrarenal functional pattern in the different segments of the nephron, the interaction, the control of reabsorption, the control of circulation. So I think, as quite often in the biological science field, it's a methodology which pushes and opens up a new insight into systems. No question that this technique had been picked up by many extremely competent laboratories in the United States, in France, in Japan, in Germany, in Sweden, which in general pushed this field of renal physiology very much and brought it to an international, highly recognized scientific field.
Even though obviously scientific developments are closely connected, where it happened, mainly in the United States and in Europe, and yet sometimes one thinks and wonders if there's a difference in the way science is done in these two regions of the world.
I don't think that today there is much conceptual or difference in renal physiology, renal kidney science between these two countries. But after the war, of course, there was an enormous gap. And what was the reason for that gap? I think the United States were fortunate in so far as during the war, Second World War, science could still develop and scientific activities were supported, and young scientists could develop on the shoulder of experienced and highly competent scientists. Whereas in Europe in general, and particularly in Germany, we had a lack of experienced scientists. Some of them left the country for different reasons, others have died, and there was a kind of vacuum in Germany, and it took quite a number of years to re-establish this background of science, and that is the development of scientists over the years, again to give the help and push and exercise younger scientists to further develop this area. So it was a time when many of us went to the United States because the availability of experienced scientists was much larger than in Germany at that time.
And was it perhaps also the political will to spend the taxpayers' money on science issues as evidenced by the establishment of the NIH in the United States as this mega funding agency?
Funding of biological and medical science in Germany primarily comes from the Deutsche Forschungsgemeinschaft. And the Forschungsgemeinschaft in those days was, I think, able to support good science in Germany. And there was no real shortage of money at that time. But over the years, the situation has changed, and particularly in the years of today, we have a shortage of money because the limitations of the federal budget also limits the support of the Forschungsgemeinschaft. The university budget had been cut down during the last 2 years by 5 to 10%, all signs of shortage of support to from the public. So we are presently experiencing a time of shortage of money for research, which was completely different in the 60s and 70s.
Is there hard evidence that science progression is retarded by the lack of appropriate funding, like as measured, for example, in the number of submitted manuscripts or whatever evidence one can
Well, that's a very difficult question, but I think for young scientists, it is less attractive in these days of shortage to join research groups and to plan for lifelong work in science. It's no question, and I think similar situation exists in the United States, that, for example, medical students hardly come to the departments of basic science anymore because they try to make their living outside of science for very obvious reasons.
Let's turn to your scientific contributions a little. You are known to have initiated the work in the tubular glomerular feedback system. Maybe that's what you're known most for. How did you come up with that idea?
Well, as I said before, I had been working initially in the field of renal hemodynamics, and also it was very clear to us at that time that one of the effector system in regulating renal hemodynamics is a smooth muscular vasculature in the kidney. However, the trigger to control the vasculature was not quite clear to us. And at the same time, we measured the relationship of renal oxygen consumption to renal function, and it became quite clear that the major component for renal oxygen consumption is the active reabsorption of tubular fluid, and particularly of electrolytes. So the idea then developed what balances these two primary functions in the kidney, that is glomerular filtration and tubular reabsorption. So there must be some kind of interaction between these two parameters in renal function, because an overflow of the tubular system with glomerular filtrate would lead to a loss of volume and vice versa. It's interesting to go back into literature, and this was something which always fascinated me at that time, that, for example, Brandt Rehberg in 1929, Brandt Rehberg was the physiologist who developed the creatinine clearance as a measure for glomerular filtrate. In a short note in one of his papers, mentioned the idea that because of that huge glomerular filtrate, it would be absolutely necessary that any damage to the reabsorptive capacity of the tubular system would automatically lead to enormous volume loss. So in other words, he also already speculated that any damage to the or change in the tubular reabsorptive capacity would have to be paralleled by a decrease in glomerular filtration rate to avoid volume loss. Then second, in the 30s, the Belgian pathologist Gormac Teague investigated microscopically actually the juxtaglomerular apparatus, and because of this anatomical connection of this little structure between the macula densa segment of the distal tubule and the glomerular elements, anatomical elements, he speculated at that time that perhaps the chemical composition of the fluid past the macula densa may in some way affect the function of the glomerular system. That was fantastic foresight, but at that time could not be experimentally investigated in detail. And it was in 1963 at the Congress, International Congress in Prague, that at a main lecture which I had the privilege to give on the renal hemodynamics, that I developed in this lecture the idea or the possibility that in part the juxtaglomerular apparatus with its function, with its connection between the tubular system and the vascular system, is a link to interact between tubular system and glomerular system. In other words, to contribute to the balance between these two functions in the kidney. And it was then in 1964 I spent half a year in Chapel Hill with Karl Gottschalk, primarily on to write an article for the Green Journal on renal hemodynamics, that I used this opportunity to develop the possibility that this juxtaglomerular apparatus is one of the crucial interlinking elements between tubular and vascular function in the kidney. Weeks were left before returning to Germany, and I went to the laboratory of Karl Gottschalk, where Margaret Meil was the expert in the micropuncture techniques, and built together with her a little setup for micropuncture for my own, and sought to test this hypothesis with a very simple experiment. It was well known that the tubular fluid at the macula densa was low on osmolarity and on sodium chloride concentration. And the concept was that any increase in sodium chloride signal at the macula densa may have a negative effect on the glomerular filtration rate. So what I did was just use a micropuncture pipette and punctured the early distal tubule and injected retrogradely an increase, a higher sodium chloride concentration as normally present at the macula densa, to see whether or not the glomerular filtration rate would respond. Now I could not, of course, measure the single glomerular filtration rate of that nephron, but a shutdown or a decrease, a drastic decrease in filtration rate should be possible to be observed in the diameter of the belonging proximal tubules. For example, a complete shutdown of glomerular filtration rate would automatically lead to a collapse of the proximal tubule, because the remaining tubular fluid would have been reabsorbed. No further filtrate is being delivered to the proximal tubule, and so the proximal tubule would collapse. And that, of course, can be seen on the surface of the kidney through the microscope. So these were the very first experiments, and I'm still having the laboratory, the book where all these documents or these experiments have been documented, and I think it was the very first successful experiment on March 6 in 1964 that the proximal tubule really collapsed when the sodium chloride concentration at the macula densa was increased. So I took this film from the camera on top of the microscope, went to the drugstore, and was so happy to see these collapsed tubule then in reality on the film. These were the very first experiments, and then of course later on this has been much more analyzed in detail, and I think we'll come to that a little bit later.
That was wonderful work for a couple of weeks. At the same meeting in Prague, there was another presentation by Arthur Guyton, who was the other major player in this particular field, and it addressed also some kind of a tubulo-glomerular feedback system. For historical records, would you say that these two developments have been entirely independent, or were either Guyton or you aware of each other's?
No, they were entirely independent. I mean, as you know, Arthur Guyton was modeling these systems very successfully, and came to the conclusion that more or less the osmolarity at the tubular fluid was the signal perceived by the macula densa. But I think that we had no interaction at that time, and the development was completely independent of each other.
It's interesting that it happened at the same time, though. The other thing that always intrigued me about your publications and your work was that you came up with this wonderfully provocative term, acute renal success. What is the background of that, and when was the term coined, and in what context?
The term acute renal success was the result of a most enjoyable and stimulating discussion I had with John Boylan in Buffalo. It was in 1976 that I visited John Boylan in Buffalo, and we thought it would be wonderful to develop this concept of acute renal failure in terms of saving volume for the organism, for circulation and for the rest of the organism. And as a consequence of the shutdown in the glomerular filtrate as a result of a decreased reabsorptive capacity of the tubular system during acute renal failure. And we we thought that this reflex, this intrarenal reflex, is a life-saving positive reflex for the survival of human beings undergoing acute renal failure. So we termed this reflex acute renal success, the unexpected logic of oliguria in acute renal failure. For a certain period of time, I think it has was a little classical. You said it's still being read.
I think it's still a classic.
It's still a classical, but it was the title, no question, was may have been a little bit sexy, or
it sounds to me like the title was first and the paper came second, because you wanted to use such a book.
Right, you mean the title was read, not so much the paper. But anyway, that was one of the most enjoyable time with John Boylan together, and it really paid it off, this visit to him in Buffalo.
Another thing where you spent a lot of scientific and organizational energy was to establish the electron probes in Munich and the facility where these experiments were done. Do you still believe in this methodology, and what were the major contributions of it?
Well, the first question is I can easily answer. I still believe in the method. The method is a highly quantitative method to measure intracellular electrolyte concentrations. The reason we got interested in this method was around 1970, 1972. The method had been applied primarily in physics and in the analysis of material, of hard and concrete material, surface analysis, but not practically not in biology. And it was, I think, Adrian Hochben in Iowa who first had thought of applying this method for the analysis of biological tissues. I visited him in, I think it was 1970 or so, 69, 1970, to look into, to see how this method works and what is needed to adjust this method for the analysis of biological tissues. And was very optimistic at that time that that can be done. And we acquired a machine here in Munich, and it took us about 3 years to develop this methodology to the point that intracellular electrolyte concentration in freeze-dried tissues can be, or slices can be measured. And I must acknowledge that in that moment, certainly the Deutsche Forschungsgemeinschaft, our major supporting agency, they supported us for 3 years during the development of that method without any paper which we could publish at that time, but they thought, okay, we will support them. And they really did that for 3 years, and it took us 3 years finally to come out 1973 with the first paper on the use of the electron probe for the analysis of intracellular electrolyte concentration. Now, at that time, we had two groups in our department were extremely active in the analysis of trans-epithelial electrolyte transport and flux rates. And this was Nagel and Dörge primarily, and they were extremely interested to analyze individual cells in those epithelial structures concerning their contribution to transepithelial electrolyte fluxes, etc., etc. Because of the inhomogeneity of these cells, it was essential to identify and to analyze individual cells. It was then only in, I think, in 1984 or so that we used this method also for analysis in the kidney, and we may come to that in a moment.
So addressing these scientific issues in a little more general terms, I think I remember that you once told me that if you want to do good science, you have to have a concept and you have to then follow it. Do you still feel strongly about it? And is that still a recommendation you would give to people?
Well, I think there's no question. I mean, you may look at yourself. I mean, it's a concept which is the important beginning of research. I mean, you have to adjust methodology and methods to follow and to further analyze a concept which you had in mind to really to as a major theme of your scientific career. And I mean, coming back to the tubular glomerular feedback system, which after you joined our group, then developed your own groups and stood in this field for lifetime. It was a concept which fascinated you, not different methods to be applied to different questions, different issues, but the concept is the beginning of a successful scientific career. And what then is needed to adopt and to pick up new developments in methodology to further look into the details of that concept. That's a very important, I think, issue of a successful scientific career.
Let me address another question. You have been the leader of a physiology department for many, many years. What were your main priorities in this function as an institute leader?
Well, different aspects. One is I always found that in a department of that size, was a rather large department, you're, as a chairman of the department, more than happy to have around you competent scientists who are able to establish their own concepts, their own scientific pathway. And I think that was one principle I tried to follow in the department, to let those groups develop on their own. Keep hands over the groups and see that we get enough money and support, but the scientific individual work was immensely important in this department. Second, I enjoyed tremendously the exposure to students, and this was one reason that I had the chance to join the Max Planck Institute. I never really was seriously thinking of leaving the university, because the lecturing and teaching and surrounded by students was one of those elements in my life which really I enjoyed tremendously, and which also stimulated me, which was certainly not so much existing at the level of the Max Planck Institute.
So physiology teaching shouldn't be done by clinicians?
Yes. Well, I think the intellectual approach to the basis of medicine, and that is physiology, biochemistry, immunology, genetics, should be an element in the educational years of the students at the very beginning, to give him the idea and the experience that whatever he is then doing in medicine is based on those concepts developed in basic science. And I think in so far I'm very much for exposing students at the very beginning to basic science.
Physiology, as you of course are aware, physiology as a field and physiology departments as a consequence have had and still do to some extent somewhat of an identity crisis. So what do you think should a modern department of physiology take to find an identity?
It all depends what you summarize under the term of physiology. As long as the presently in most departments performs science at the molecular and cellular level is coupled and matched and controlled by a functional analysis. In other words, what does it mean when, for example, a transport protein has been changed? Is that effective on the transport system per se as measured under functional conditions? In other words, the functional control remains an essential issue, and so far I think one should be very clear about it, that departments in physiology should fulfill this function in science. Also, they incorporate in their own work, of course, the very forefront modern approaches in biomedical research on the molecular and cellular level.
Should physiology departments remain within the frame of a medical faculty, or should they form their own entity, as happens now sometimes?
Well, that's a critical question. I think, first of all, medical students need to be trained and in physiology, specifically in the organ function, and that is something which requires the departments of physiology. When it comes to research, it is really very difficult to say whether or not the research in the present research in the Department of Physiology are directly linked to medical problems. That's a very difficult question. I think the gap between the research done in the forefront departments of physiology and the bedside problems is enormous, and one of the typical examples I think is presently in the field of neuroscience, which is so far in terms of research, so far away from the problems in the neurological departments in the hospital. But this is true for other areas too. Less probably for the departments of physiology, which are concerned with circulatory and vascular research. That remains still a field very much linked to medical problems.
You always have been one of the physiologists who had an intense interest in clinical issues. For example, it must have been the second or third paper that you and I did together on tubular feedback that had a clinical issue, whether it played a role in acute renal failure. So do you think that it would be a goal that all physiological knowledge should in some way or other be translatable to the bedside?
Certainly not all, but in one or the other instance, it may have a direct impact on problems in the hospital. I mean, what you mentioned was the papers which we together published on the pathogenesis of acute renal failure, where we thought that part of the shutdown of the glomerular filtrate is due to the tubular-glomerular feedback mechanism. This immediately was picked up by the clinicians as a possible mechanism to understand the mechanisms behind acute renal failure. But looking back today, I must say also many other aspects had been analyzed. We are still far away from really understanding those intrarenal mechanisms which come together to shut down the kidney and to lead to this reversible acute renal failure. It's probably still a long way to get a clear picture of the different mechanisms, but that was the beginning of a very close relationship between clinical nephrology in those days, and they were extremely interested that for the first time actually a concept based on physiological functions of the kidney was developed to understand better acute renal failure.
In a more general framework, where do you see the future of nephrology is? Where is it going? And what is the role of physiology in nephrology?
What is the future of nephrology? Well, I think one unsolved problem, despite the enormous activities in analyzing detailed cellular and integrated renal function, remains the lack of any causal treatment of a diseased kidney. So I think this is a goal and something which nephrology must keep in mind, that the final answer hopefully in one day will come up, and that a diseased kidney can be treated not only as in these days phenomenologically by transplantation or dialysis, but a causal treatment of a diseased tubular cell or vascular cell. And that we are still far away from that, but I think that is still existing enormous challenge for nephrology in the future. The role of physiology in this development or in other similar areas remains to be seen. I think the capability of analyzing functional parameters in the kidney remains a topic of renal nephrology, of renal physiology.
Right, if in this concept of the future of nephrology, physiology has a natural place, obviously.
Absolutely.
So to turn now to another issue, that of you and the International Society of Nephrology, it struck me that you are the only physiologist, as far as I could tell, or the real card-carrying physiologist who has been the president of the ISN. What do you think explains this impact you had, and what are the memories that are most vivid in regard to your presidency?
It's the first time I realized that I was the only physiologist as president of ISN, but I think one reason for that was that I first had a very close contact to clinical scientists. Part of the work we already discussed, which was relevant for nephrologists working at the clinical level. Second, before I became president of ISN, I was internationally very active in the science community. I was at the Council of the International Union of Physiological Sciences for quite a while, was chairman of the Renal Commission in this union, and then was at the Council of the International Council of Scientific Unions in Paris, which again brought together many scientists from different areas and different countries. So to speak, I think the internationality of my work was part of the possible decision that the Council of ISN then elected me as president of ISN.
And do you have what are the memories that you connect with it and that really remain?
Well, at that time we had a fantastic members of the council. I mean, this is the working group in ISN which works almost on a daily basis together. And one man I should mention, because he was a great person, great friend. He was the general secretary of ISN, and that was Claude Amiel, who unfortunately died too early. But Claude was a remarkable person, very intellectual, and also balancing between the different views always expressed, of course, in the council. But it was a fantastic group. The past president at that time was Dan Zeldin. The incoming president was Ike Robinson. Bob Schreier was on the council. So in other words, I have only very great memories on that time, and it was...
well, the greatest memory must be related to being the president of the ISN Congress, right?
Well, that was quite a great experience, and that was in Tokyo in 1990, and we can look over a few pictures. I mean, with Claude Amiel addressing the audience, Professor Oshima, who was the local president of the Congress in Tokyo in 1990, Ike Robinson, who was the incoming president, so from 1990 to 1993. I should mention one colleague in Tokyo who helped me personally and professionally very much to in the development of this and the work for this Congress, and to make this Congress a great success, and this was Professor Zugino. Professor Zugino was in Chapel Hill for a while, so he was an internationally trained person, and he really was a man who had this insight in the needs of the interaction between international scientists and local scientists in Tokyo to make this Congress a success. And Sugino was extremely helpful. And second, or lastly, Kurokawa, who then later on became president of ISN, at that time had returned from the United States to Japan, and he, also with the help of Sugino, got involved in the scientific structure and organization of the program, and Kurokawa was the most stimulating and effective member of the scientific committee of that Congress.
Since we are at the issue of the ISN Congress, one sometimes wonders what the role of such a gigantic Congress as that is nowadays. How do you see this?
Well, the Congresses of the International Society of Nephrology, I think, have changed their aims compared to the very beginning. In 1959, it was a forum for nephrologists, for clinicians, for basic researchers to interact with each other, but primarily from countries where research was in full flower. The United States, West Europe, and Scandinavia, Italy. But over the years, the character of this Congress, I think, has changed correctly, because no doubt the ASN Congresses, the yearly Congresses in the United States, are so international that any further international similar Congress run by ISN would have been a duplicate or not really very effective. So ISN realized that their primary role now is to bring nephrology to areas where nephrology, basic or clinical, is less developed than in countries we mentioned before. So the present idea is to have congresses in cooperation with local, regional organizations in the renal field, and bring the experts and the people to those places to stimulate not only the local nephrologists and give them an international reputation, but also tell the government and the supporting agencies how important this is for the people, for their society, that renal research and nephrology become an important issue in their decisions. And I think, and so far, the ISN fulfills a very important function in those areas of the world where, as I said, nephrology has not yet developed to that level as in the developing countries.
Could you give a specific example?
Well, I mean, I remember very well that, for example, the Congress of Nephrology in 1990 in Tokyo was at the time when nephrology in Japan was certainly not that developed as it is developed now. I think, in other words, the Congress was an enormous stimulus for nephrology in Japan, and similar in South America, not far ago. We had a fantastic, not in Congress, but workshops and symposia in Africa, and which has led to the formation of the African Nephrological Society. So in other words, I think here is the place where the International Society plays an enormous positive role in developing and pushing nephrology in those areas.
Not perhaps just by organizing congresses.
No, whether or not the Congress is the most effective measure for those developments, I agree, I would question that. More important are smaller meetings and more intensive interaction between individual scientists, as can be done in international huge congresses.
And the realization of that perhaps led to the establishment of the fellowship program, the international fellowship program.
Correct. The fellowship program is one important component in this respect, but also I think the forefront symposia, which had been developed by ISN, which brings together scientists from the, I should say, inner circle of nephrology and scientists from outside nephrology to interact, and that in different places of the world. That again is, I think, more effective than any of these huge international congresses.
Maybe one can say that you have been, you certainly have been active and perhaps an activist ISN president. You try to get the ISN into the International Council of Scientific Unions, and you suggested the formation of a number of ISN commissions and a number of other things, among them the forefront symposia. So if you look back on that presidency, what do you think were your main achievements, and were there any disappointments?
Well, to begin with, a disappointment is perhaps to mention the idea of having ISN as a member of the International Council of Scientific Unions. Now, what this International Council is, it is an umbrella organization for international scientific unions and organizations and academies. And I thought that by having ISN incorporated in this international community, the interaction with other relevant scientific unions and exchange with them in programs, in supporting other interdisciplinary programs would be more effective. Maybe that was too much to ask for, because in other areas like in water research or climate research, this international interaction is essential. Perhaps that was too much to ask for in the case of nephrology. This connection has not really led to any obvious results. Maybe one day or another, not at the present time. Now, the other more effective development was the establishment of scientific commissions. Again, the idea of having a smaller group of scientists, which we would define as belonging to nephrology, and scientists from outside, immunology, genetics, cell biology, etc., to interact in these commissions and have joint meetings, which has finally led to something still existing and very successful. The idea, and I think primarily one of the driving force behind this development was Ike Robinson to establish the forefront symposia in nephrology. In 1989, these forefront symposia had been established as a formal official program of ISN, and the director of this program for many years, from the beginning on, was Gerhard Giebisch, and Gerhard did a fantastic job in directing this program so that this became a great success, and the forefront symposia are still one of the major programs besides other supporting programs for younger scientists, etc., in ISN.
One last question, if I may. There are parallel societies in the international arena in the field of nephrology, like ISN and the European ERA, EDTA Society. How do you see how do you see the necessity of coexistence between these societies?
Well, we have regional societies in the different areas of the world. For example, the ERA, EDTA in Europe, the Asian Nephrological Society in the Pacific. I think there is a need for those regional groupings because of specific problems related to the geographical area, whether these are religious, ethnical, organizational, political issues which differ from area to area, from region to region. And so far, I think the interaction of scientists and clinicians and regional groupings is a contributing element to the development of, this case, nephrology in their specific region. Besides that, the international societies, the International Society of Nephrology, ISN, has an umbrella function in nephrology, the global dimension, and insofar it is complementary to ISN, but not superfluous.